This is SpaceTime Series 27, Episode 126, for broadcast on the 18th of October 2024. Coming up on SpaceTime, NASA's Parker Solar Probe completes its 21st flyby of the Sun. The Webb Space Telescope discovers a potential missing link to the universe's first stars. And mission managers have fixed a key science instrument aboard NASA's Perseverance rover. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Parker Solar Probe has completed its 21st close encounter with the Sun. The flyby equalled its own previous distance record, swooping to within 7.26 million kilometres of the solar surface. The close perihelion approach occurred at a record speed of 635,300 kilometres per hour, again matching its previous record encounter speed. After the flyby, the spacecraft checked in with mission managers at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, using a beacon tone to indicate that it was in good health and all systems were operating nominally. The close encounter set the probe up for another close flyby of Venus. This close approach marked the last time that Parker will fly around the Sun at this distance and speed before it makes the first of three final closest approaches. They'll begin on December the 24th. Now, at this point, with its orbit being shaped by the mission's final Venus gravity assist on November the 6th, the spacecraft will swoop down to just 6.1 million kilometres from the solar surface, moving at over 692,000 kilometres per hour. That's the fastest any man-made object has ever travelled at. Launched aboard a Delta IV Heavy from Space Launch Complex 37 at the Cape Canaveral Space Force Base in Florida back in August 2018, the Parker Solar Probe is on a 7-year mission studying the Sun's outer atmosphere, the corona. The mission's undertaking 24 highly eccentric orbits around the Sun, flying deep into the corona. It'll trace the flow of energy that heats up the corona and accelerates the solar wind, the constant stream of charged particles flying out from the Sun and bathing the entire solar system. As well as detecting the sources of the solar wind, it'll also determine the structure and dynamics of the Sun's magnetic fields, and it will work out the mechanisms which are accelerating and transporting energetic particles. The $1.5 billion spacecraft carries 4 scientific instrument suites designed to study magnetic fields, plasma and energetic particles, and capture images of the solar wind. This report from NASA TV.
Liftoff of the mighty Delta IV Heavy rocket.
In August 2018 in Cape Canaveral, Florida, NASA launched Parker Solar Probe to touch the Sun.
Parker Solar Probe is touching the Sun.
This is Noor Rawafi, the project scientist of the mission. He has been waiting for this moment since the beginning of his career.
This is a dream come true. One of the major goals for the Parker Solar Probe mission is to fly through the solar corona, and we are doing that now.
So what does it mean to touch the Sun? To answer that, we need to look at the Sun's structure. Unlike Earth, the Sun doesn't have a solid surface. It's a giant ball of hot plasma that's held together by its own gravity. Solar material flows out from the surface, but around the Sun, it's bound by the Sun's gravity and magnetic field. This material forms the Sun's atmosphere, the corona. Eventually, some of this hot and fast solar material escapes the pull of the Sun and gushes out into space as solar wind. The boundary that marks the edge of the Sun's atmosphere is known as the Alfvén critical surface. We didn't know exactly where this boundary was, but for the first time in history, a spacecraft has crossed it. Parker Solar Probe ventured into the corona, touching solar material still bound to the Sun. The wispy corona is too faint to see most of the time, but it's revealed during total solar eclipses. For centuries, we've been studying the Sun's atmosphere during eclipses because it's important for understanding how a star influences life in the solar system. But much about the corona remains a mystery.
2 of the most challenging scientific mysteries in astrophysics occur in a region that we call solar corona.
The first mystery is about the temperature. The corona is about 300 times hotter than the photosphere, the visible surface of the Sun below. Secondly, there's a constant stream of particles flowing from the Sun known as the solar wind. It accelerates up to millions of miles per hour out of the corona, and we don't know how. Solar wind can disrupt our satellites and technology. To better protect them, we need to go where the solar wind starts, in the corona. So heading there has been a key goal of NASA's for a while. We first proposed the idea of sending a spacecraft to the sun in 1958. We didn't have the technology to withstand the journey until the 2000s. Since its launch in 2018, Parker has been heading towards our star. Then, in April 2021, during Parker's 8th orbit around the Sun, the spacecraft was around 20 solar radii, or 8 million miles from the Sun's surface, when it crossed into the corona.
This is a huge milestone. It took us over 6 decades to come to this point.
As Parker entered the corona, its whisper instrument took the images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away at high speeds so that it can't return back to the sun's surface. Inside the corona, the sun's magnetic field becomes much stronger. Solar material is slower and tethered to the sun. Instead of a smooth divide, Parker found that the boundary between these two sides is wrinkly. These bumpy ridges are created from huge flows of plasma traveling out of the corona. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. Before entering the corona, Parker had seen kinks in the solar wind where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed. In 2021, the spacecraft finally tracked switchbacks to one of their origins. As Parker got even closer to the sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the sun. As heat rises beneath, these convection cells churn and create funnels of magnetic energy above the surface. Scientists found that switchbacks form inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle, though. Exactly how they form is still unknown. Over the next few years, Parker will keep looking for clues as it explores our sun, the only star we can study up close. The sun is also the only star known to support life, so understanding it is critical as we search for life beyond our solar system.
That will link directly into the question, are we alone in this universe? And that is one of the biggest questions for humanity to answer.
This is SpaceTime. Still to come, NASA's Webb Space Telescope finds a potential missing link to the first stars in the universe, and mission managers have fixed a faulty science instrument aboard the Mars Perseverance rover. All that and more still to come on SpaceTime. Astronomers looking deep into the early universe with NASA's Webb Space Telescope have found something unprecedented, a galaxy with an unusual light signature which they're attributing to gas outshining the stars. Found approximately 1 billion years after the Big Bang, the galaxy GSND G9422 may be a missing link phase of galactic evolution between the universe's first stars and the familiar well-established galaxies we see today. The study's lead author, Alex Cameron from Oxford University, says his first thought in looking at the galaxy spectrum was, that's weird. So Cameron reached out to his colleague Harley Katz, a theoretical physicist, in order to determine the strange data. Working together, they developed computer models showing that cosmic gas clouds heated by very hot massive stars, to the extent where the gas would shine brighter than the stars themselves, was nearly a perfect match for the Webb observations. Study co-author Katz, also from Oxford, says it looks like these stars must have been far hotter and more massive than what we see in our local universe today. And that makes sense, because the early universe was a very different environment. In the local universe, typical hot massive stars have temperatures ranging from between 40,000 and 50,000 degrees Celsius. Now, according to these new observations reported in the monthly notices of the Royal Astronomical Society, galaxy GSND G9422 has stars hotter than 80,000 degrees Celsius. The authors suspect that this galaxy must have been in the midst of a brief phase of intense star formation, deep inside a cloud of dense gas, and that's what's producing the large number of massive hot stars. The gas cloud is being hit with so many photons of light from these stars that it's shining extremely brightly. Now, in addition to its novelty value, nebula gas outshining stars is intriguing because it's something predicted in the environments of the universe's very first generation of stars, which astronomers refer to as population 3 stars. Now, Katz says this galaxy does not have population 3 stars. That's because the Webb data shows it's got far too much chemical complexity. However, its stars are definitely different from what we're familiar with today. And so the exotic stars in this galaxy could be a guide for understanding how galaxies transition from primordial stars to the types of galaxies we know today. Now, at this point, this galaxy is just one example of this phase of galactic development, and so there are many questions which still need to be answered. For example, are these conditions common in galaxies from this time period, or is this a rare occurrence? And what more can galaxies like this tell us about this earlier phase of galactic evolution? So Cameron, Katz and colleagues are now actively identifying more galaxies like this to try and add to this population in order to better understand what's happening in the universe within the first billion years after the Big Bang of creation. This is SpaceTime. Still to come, mission managers have repaired a major science instrument that had broken down on the Mars Perseverance rover. And later in the science report, a new study has confirmed that people simply don't know how much they really don't know. All that and more still to come on SpaceTime. Well, after more than 6 months of efforts, NASA mission managers and technicians have finally been able to bring one of the Mars Perseverance rover's most important scientific instruments back online. Sherlock, the scanning habitable environments with Raman and luminescence for organics and chemicals, stopped working back in January. This key spectroscope uses fine-scale imaging and an ultraviolet laser to determine detailed mineralogy and to detect organic compounds. Sherlock was so important because it would be used to help assess the habitability potential of rocks and soil samples and their aqueous history. And that means it would help scientists determine if there were potential biosignatures preserved in Martian rocks. And it would also provide organic and mineral analysis for selective sample caching, helping to select the rocks that would be brought back in a sample return mission. And it doesn't end there. Sherlock was also designed to examine the availability of key elements and energy sources for life on Mars, including carbon, hydrogen, nitrogen, oxygen, phosphorus and sulfur. However, all that came to a crashing halt back in January, when one of the instrument's key motors suddenly caused its dust cover and autofocus mechanism to become inoperative. This was an important piece of scientific equipment aboard the car-sized robotic rover, and its sudden failure was a serious blow to the Perseverance mission in Jezero Crater. Now, fortunately, a motion by the robotic arm 2 months after the initial issue occurred resulted in the dust cover moving nearly to the full open position. And as a result of that, mission managers began to look at new ways to try and focus the optics and operate Sherlock with the dust cover left permanently in its open position. Now, these efforts involved numerous trials and errors and multiple rounds of diagnostic examinations, analysis and troubleshooting. After a lot of hard work and persistence, the team were able to successfully bring Sherlock back online, with a successful observation of the rock target Walhalla Glades. And since then, Sherlock's Raman capabilities, whose destiny was uncertain a month ago, performed multiple calibrations, scans and observations of another rock, Shayava Falls. And scientists were thrilled to discover what is now the most compelling evidence for organics in Jezero Crater. See, organic compounds are important because although they can be formed by non-biological processes, they can also be formed through biological processes. And the organics that Sherlock's observed in Shayava Falls would need to be studied in laboratories back here on Earth for their origins to be determined. Regardless of how they were formed, the Shayava Falls organics will tell scientists a great deal about the red planet's past and present carbon inventory, a possible early carbon cycle, and the precursor conditions for life as we know it. This is SpaceTime. And time now to take another look at some of the other stories making news in science this week with a science report. A new study has shown that consuming more caffeine may improve your heart health. A report in the journal Rheumatology has found that caffeine, which is present in coffee, tea and cocoa, actively helps endothelial progenitor cells. They're a group of cells that help regenerate the linings in blood vessels and are involved in vascular growth. Vascular disease, damage of blood vessels and their resulting consequences, such as heart attack and stroke, are among the leading causes of death in the general population. And in patients with inflammatory rheumatic diseases, such as lupus and rheumatoid arthritis, these risks are even greater. Researchers investigated 31 lupus patients without traditional cardiovascular risk factors using a 7-day food questionnaire. After a week, the investigators took the patient's blood in order to measure their blood vessel health. They found that patients who consumed coffee had far better vascular health as measured through their endothelial cells. A new study has found that 35 years of satellite observations have shown that plant cover is increasing along the northernmost part of Antarctica. The researchers found that areas of vegetation on the Antarctic Peninsula have increased from less than 0.9 square kilometres to almost 12 square kilometres. That's roughly 14-fold increase between 1986 and 2021. The findings, reported in the journal Nature Geoscience, show that the rate of greening was higher in 2016 to 2021, which could be linked to lower sea ice cover, causing warmer, wetter conditions. The authors say their observations could be explained by the spread of existing moss-dominated vegetation, but that mosses help convert rocky surfaces into soil, which could make it easier for other plants, including invasive species, to spread in the future. Well, over the past year, the world's been horrified by news reports full of protests by people concerned about the Middle East, but who it turns out have absolutely no knowledge or facts about the history behind the events. In many cases, they don't even understand that they would be the first to be shot, stoned or thrown off tall buildings were they to actually visit the groups they're often violently supporting, a syndrome which is jokingly now known as chickens for KFC. Now, a new study has explained what's going on. It turns out people simply don't know that they don't know what they don't know. A report in the journal PLOS ONE has shown that people are biased to assume that they're not missing crucial information when it comes to them forming an opinion about any given situation. To reach their conclusions, the authors recruited more than 1,000 participants and presented them with a hypothetical scenario where they needed to recommend whether two schools should be merged or not. Some were given information about the benefits of the merger, others were given information about the benefits of not merging, and some were given both. The researchers say participants in all groups were equally likely to think that they had enough information to make a call, and they were heavily influenced by the information they received when making their decision. But none bothered to seek out more information in order to gain a more informed opinion. The researchers say this assumption that people know enough to form an opinion may be the source of much of the conflict in our lives today. A new study has again confirmed that when placed under strict scientific testing, astrologers are no better than chance at determining someone's character, their past, or their future life. The findings come despite clear evidence that astrology is very popular, with both Gallup and YouGov polls showing that some 25% of Americans believe that the position of stars and planets really can affect their lives, and an additional 20% being unsure of its legitimacy and not willing to rule it out. The latest study by clearthinking.org wanted to see if astrologers could use astrological charts to understand a person's character and life. Tim Mendham from Australian Skeptic says 152 experienced astrologers took part in the study, yet not a single astrologer got more than 5 out of 12 questions right, making their performance indistinguishable from pure random guessing.
There was a recent study done of astrologers to see if they could actually match up birth information, time, day, date, place, that sort of information, and character assessment as well, and see if they could do a blind test. So they're given a character assessment of someone and see if they can match it up with the birth astrological information. This sort of thing is done every generation or so. It comes up with the same result. No, they can't do it. They're no better than chance. If they're given 5 different character assessments or one character assessment of 5 different astrological charts or vice versa, and if they pick it, so you got one chance in 5 of getting it right just purely by chance. And lo and behold, what these astrologers, and these are serious astrologers and ones who always say I'm going to get 10 out of 12 or something like that, they get 1 out of 5 right or thereabouts. Most of them were purely aligned with chance, and so what they said they can do and what they thought thought they were doing. And while they were doing it, they were saying, we're going really well. This happens all the time. But they turned out that they weren't. And apparently there's about a whole lot of different types of astrology, and this test was a pretty decent test, and they go to great lengths to explain how it was. All these different types of astrology, they all came out with the same result. Chance, pure chance. You can't do what you say you can do. And this is what the skeptics are all about, testing people. We've got a $100,000 challenge. Show us what you can do. If you can do it under strict scientific conditions, you're going to get $100,000. And people therefore come out, and we've done a lot of tests for people, and none of them have ever been able to show that they can do what they say they can do, right? It takes a pretty undiscerning audience to think they're genuine, and the skeptics are quite the opposite. We're very discerning, if you like, but keen to find out. We got 100,000 real money, keen to find out. Let's do it. We've tested astrologers, we've tested water diviners, psychics, palm readers, all sorts of different things, all sorts of technologies and things, and none of them have actually been able to do what they say they can do. And of course, people see that, say, yeah, okay, and then they go away and say, well, the test was wrong, even though the test was not wrong.
You've always got to find some sort of self-justification.
They always find a solution within hours normally, perhaps even less, that either we cheated or the test was always agreed to beforehand, and then they say the test was unfair. If astrologers, whether they gave reasons for it, they probably would have said it's just a bad day. But no, a lot of astrologers were tested, 152, tested with these charts, and they got no better than chance. You and I could do just as well as they did.
That's Tim Mindham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.